Well done.
Are we going to stand here, or do you want to sit down?
Yeah, let's stand. So
let's stand.
Give Bob a hand first here. So I'm going to quiz him for about 15 minutes, but this is also, I would be especially, there's feedback in this room.
That was me breathing.
That was you breathing, okay. I still haven't gotten error correction for analog yet. But I also would love to bring in comments or questions from the audience. And here's how we're going to do questions and comments. I'm particularly interested in the folks who were part of this revolution. If you have a question, so everybody just practice me, do this. So come on, everybody in the room, raise your hand. Good, I know you all do it. If you have something that you just absolutely need to toss into this conversation at that exact moment in time, do this. Put up 2 hands, we'll bring it to a screeching stop, and we'll get a microphone to you. Does that sound cool?
Cool.
So go back a slide. Let's see if they can do it. Yeah. Because the other aspect about Bob is he is a fearless prognosticator. And he prognosticates often, and has been teased terribly for some statements where people decide he wasn't quite right. There was that period in the 90s when you were kind of dissing wireless.
I was right about that.
We're coming to that. You're finishing my thoughts. As someone who prognosticates for a living, I count on people like Bob because I get some of my best ideas from listening to him. So I love starting with this very tantalizing slide. Looking ahead, what's the biggest surprise you think we're going to see in the next 3 to 5 years coming out of the telecom space?
Hard question. To me, the most exciting surprise, I think, is going to be MOOCs. So most of us have gone to college.
Does everybody know what a MOOC is? Massively open online courses.
So education is about to be disrupted. Most of us in this room probably got educated along the way. And that whole thing is about to get, like iTunes into music and
you didn't do bad for a guy who, never made it to Stanford.
I took management of high technology at Stanford University.
I take it back. Yeah. That was the maraschino cherry. Anyway, but yes. You're right. And Stanford is ground zero.
So the MOOCs are happening. And you all know what a MOOC is and are generally in favor? Or do you have serious questions about the loss of interpersonal contact between the teacher and the student? Do you have those kind of worries? So here's how I handle those. It goes back to the invention of another bad idea, the BOOC, the B-O-O-C, which is today spelled B-O-O-K. It was obviously a very bad idea because before BOOCs, we would sit around the campfire and we would hear the story directly from the storyteller. But now we have these damn BOOC things. So now, like you've read The Great Gatsby, but you've never met F. Scott Fitzgerald. That's a problem. So the MOOC is really a bad idea.
Okay. But
you weren't expecting
you're not
that
getting
kind of
off that
answer,
easy.
No.
You're not getting off that easy. I mean, at Stanford on MOOCs,
Stanford keeps coming up here.
Well, it's just up the road. Udacity launched, Coursera's launched. We got 2 big operations. It's going to revolutionize things. What do you see? Just 1 or 2 tantalizing specifics of how MOOCs change things with education.
Well, for one thing, education is not going to occur between the ages of 5 and 22 anymore. Education becomes a lifelong learning thing. So I'm taking 600X through edX. It's Introduction to Computer Science and Computer Programming. I'm learning Python from my own desk in Austin, Texas. My son is at his desk in San Francisco. We're both taking the course, not that there's anything competitive going on there. And I'm older than 22, and I'm learning Python. And I think there's going to, so there's elimination of this age discrimination. There's age discrimination going on at universities. I'd have a hell of a time getting admitted to the University of Texas, or Stanford, excuse me. Just mentioned Stanford.
Well, back in 2005, I was having lunch with a friend, and I told him, we're both approaching 50, and I said, I know the definition of middle age. I'm a professor at a university that would not admit me again as a student. And I own a house in Hillsborough that I could not afford to buy again if I had to buy it. So when the 2008 crash happened, I felt so much younger because at least then I could own my house.
I see.
But
So age and wealth. It costs a lot of money to go to Stanford. What, 50 grand a
$50,000 a
year?
year.
So with edX, or the other methods, the other kinds of MOOCs, or they're only called MOOCs for now. They'll be called something else as they evolve. But now anyone, anywhere in the world can take Stanford or MIT or Nexus courses anywhere. So MIT recently reported on the people who are currently taking 600X with me, and they believe that there was a person in that course from every country in the world. There was some debate about how many countries there were and whether they counted Texas or not. But there was somebody from every country in the world, some of whom had these really hard, they were taking MIT's freshman programming course from a hut in Bangladesh. So second is getting to the other 7. We're basically, like we solved bandwidth with the internet, we're now going to solve ignorance with the internet.
Well,
that was grandiose, wasn't it?
I absolutely think it is. Bob, you know, one of his many qualifications is he's got a law named after him. How many people know what Metcalfes Law is? Show of hands. And the laws, one never names a law after oneself. That would be unbelievably gauche. This was conferred or inflicted on Bob by George Gilder back in the mid-90s. And Metcalfes Law says the value of a network goes up as a function of the square of the number of participants. So that, you know, the more people you put together, it doesn't just become arithmetically better, it's non-linearly better. And I think MOOCs are a wonderful instantiation of Metcalfes Law. And I agree with you. The change is this isn't about everybody listening to the professor. This is about peer interaction using the professor as an excuse.
The MOOCs don't do that very well.
Yeah.
Yet.
Yes.
But that's a problem that the MOOCs need to solve, is getting a scaling method of peer-to-peer instruction
Well,
going.
is Dave Liddell in the audience?
No.
He's not. Well, but Dave likes to say that whenever we have a new technology, we tend to pave the cowpaths. We always do an old thing with the new technology, and then it takes us time to get around to doing the big innovations. Which, question for you, when did you realize that, you know, this thing you started with a memo on May 22nd was going to be a really big deal? How long before you realized?
Well,
I mean, other than finally getting your Harvard degree, which I realize is a big deal, but.
Well, there's 20 times.
20 times.
20 times, not just one time.
Okay.
So one of the times was, and Dave Boggs will remember this, we, for a while there, where are you, David? David Boggs. So we built the first 2 Ethernet controllers for the Altos, Michelson and Morley. And then there was a cubicle area, and then all of the Altos in that cubicle area were all connected. And each of the research scientists got to buy an Alto, and there was a little box. Did you want Ethernet or not? Ethernet was an option.
Let's run the mic over to David there, get him in case he has a comment. So keep going.
So Ethernet was an option for a short period of time. And so here's the first answer to your question. One day, somebody removed the terminator from the end of the coax for some reason. They're beautiful things, those little terminators. They feel good in your hand. And so somebody stole it, which meant that the cable was no longer functioning. And what happened was 10 people stood up, looking over the cubicles, wondering what had happened. And in that moment, we realized that Ethernet was no longer an option. And thereafter, that box was removed, and people got Ethernet every time. So that was the...
And I was thinking that, I mean, today, you know, there's communications, networking has become like oxygen. You know, if you lose it for a couple of seconds, you notice it's missing. You're starting to get a headache at 30 seconds, and you're unconscious in 2 minutes.
So I left my iPhone in the hotel this morning. Imagine how I feel now. Excuse me, I just need to hold on to something.
Dave, yeah, you can borrow my iPhone. I got to get a new one. Dave, did you have a comment after you?
No, No, he told the story correctly.
Okay. That may be a first.
That could be a
we're
first,
doing pretty
yeah.
good here. So we have about 2 minutes left. If there was somebody with a question, we'd take a question right down in front. So it also, the way we do questions is look where the person holding the mic is, and then the person in the room farthest from them, raise your hand. It's to give them exercise. Tell us who you are, your question.
I'm Thierry Trebon from 01 Informatique in France. So in 1988, were you afraid of Token Ring?
Afraid of?
Were you afraid of Token Ring?
Yes, imagine this. Imagine for about 10 years, every day, your wife, your board of directors, all of your employees, every market analyst around would tell you that you were doomed. And that the IBM Token Ring, because IBM made standards, it was the dominant computer company, they foisted what I like to call SNA on us. And Token Ring was coming, had come, and was eventually, I mean, there were a few people enthusiastic about it, but basically IBM was going to kill it. And imagine living like that for 10 years, and then Ethernot beat Token Ring, so that has scarred me. So for example, I don't take advice very well, because for 10 years I ignored all this advice, and it worked out. So I'm hoping to recreate that. So yes, terrified because of the power of IBM and their dominance. What they underestimated was the power of an open standard, and I'm referring to the old IBM now. There's a new company called IBM, which is different. But in that old IBM, in its dark little heart, was not committed to open standards, and its products were not interoperable. 3Com Corporation shipped IBM Token Ring before IBM did. And we had trouble selling it because our version of the Token Ring didn't have SNA dust sprinkled all over it. So we had
we got a two-hander over here. Say who you are.
Hi, my name's Jeff Thompson, and Bob knows me from way back. Were you ever afraid of AT&T? I mean, AT&T had ISDN that was supposed to be their answer to data.
ISDN ran at 56 kilobits per second?
Yeah, that was fast.
56, that was kilobits per second here. Ethernet started at the M level.
That's faster than 300.
I refuse to answer that question.
I was real afraid of AT&T 40 years ago today, but that was only because of AT&T security.
By the way, there's a new AT&T, and it's headquartered in Dallas, Texas.
So, we got, yes, please.
Just for the record, your wife did not say you were doomed for 10 years?
And that was someone with deep inside knowledge on what his wife said. So, last question before we push on. Failure. I mean, I kidded you a little bit about your PhD, which is in the normal nature of things. And you've had an extraordinary arc of a career. You've crammed more careers into the last couple decades than most people cram into their entire lives. One of my favorites was you were publisher at InfoWorld, a magazine that for 5 years refused to let you be a columnist. Stuart Alsop, as I remember, wouldn't let you be a columnist, and then you ended up as publisher. Talk about this. Stuart told me. Okay, well, maybe I'm wrong.
Robin, did Stuart? Oh, no.
Okay, so talk about that. We think of entrepreneurship as all about success, and yet we know most entrepreneurial ideas fail, most entrepreneurs fail, most Silicon Valley companies fail. You know, this is why, as we say, venture capitalists sleep like babies. They sleep for 2 hours, wake up and cry, sleep for 2 hours. And you've been a venture capitalist, so you've been on both sides of the risk of failure. What insights do you have for the rest of us about how do you deal with the prospect of failure? How do you make failure into success?
You don't fail on purpose. People say failure is really good and we do it a lot, but that doesn't mean you should do it on purpose. So failure is a frequent consequence of attempting something hard. And then I'll share the conventional wisdom, which is you need to fail fast. So when and this is a problem, once you start doing something, you become committed to it, and then when you, long after you should have abandoned it, you stick with it. So failing fast is an important thing. I'm not sure I was ever very good at that, and then failing fast.
Also, if you haven't, for those of you from outside the country, you know, this is the Bob Metcalfe. I'm not real good at pool, but I like to play for money. Never been on this riverboat before, right? That you're not real good.
You suggesting that I'm hustling you?
No, I'm saying that you're very modest.
Modest, yes. Well, some people have so much to be modest about.
There you go again.
Yeah.
Good. Well, I think we're right at the end of the time. If there was...
No, we got 3 minutes and 30 seconds.
No, it's going the other way.
Oh, it is.
This is a software developer's clock that keeps counting past the deadline.
Oh, I see. Yeah.
Yes. Good. So let's give a hand to Bob. He'll be back up in a bit. Good. And so now we're going to go into our first panel. Why don't you put the names up? I'll invite our first panelists up, Norm Abramson, Dave Boggs, and Bill Hawe, and Radia. Sorry, I'm going to get this right. I have another friend called Radia Perlman. Radia, I swear I will get this right eventually. Good. Come on up and grab a seat. So this panel, as we start here, this is meet the inventors of the Ethernot. And let's see, where can you put me down on this side and just shift everybody down one? Yeah, that's good. And the way we're going to do this, so we have, let's see, okay, got everyone. So, Radia, you're right next to me. Fabulous. We have 30 minutes. We have 40 minutes? 9:15. So, I'm going to shift this so I can see it from over there. Our time is short. You're going to learn more about each of these individuals in detail. We agreed in advance that the way I would introduce people is with haiku, rather than go down the lengthy careers and many distinguished accomplishments of them. So, Radia, 10 base T. Norm Abramson.
Wrong.
Spanning tree.
Spanning tree, sorry.
It has a T in it.
Sorry, spanning tree. Norm Abramson, ALOHA. Dave Boggs. Coinventor. Can we leave it at that, or? Yeah. Okay, he agrees. And Bill Hawe, Dick's Internet. So let's get started here. I want to start with you, Dave. Co-inventor, what exactly does that mean? Tell us what it was like to be co-inventor.
Well, it was Bob's idea. I just helped him reduce it to practice, as they say. I was a grad student at Stanford, and every Friday afternoon, the master's candidates were required to attend a lecture from outside people, and they took attendance. Friday afternoon, mandatory lecture at 3 o'clock, and they took attendance. So one time Alan Kay gave a talk. He mostly talked about small talk, and that pretty much went right over my head. But at the end, he showed a bunch of pictures of 6-foot-tall equipment racks full of blowers and cards, and he said they were building a PDB-10 clone. So I was exploring doing a PhD research in high-performance CPU design, and that caught my attention. So I pestered Alan for a job at the Learning Research Group, and he looked at my resume, which is I'd worked at NBC as a broadcast engineer and built a lot of hardware. So he passed my resume on to another group that was doing a clone of Doug Engelbart's video terminal. What's the name of the Doug system? Anyway, the
NLS, Augment.
NLS, yes, right, at SRI. Because I had background in television, I ended up in that group fixing the televisions. The system was based on 15 Data General Nova computers that were all lashed together with the Data General Nova Data General proprietary network, time division multiple access system called the Multiprocessor Communications Adapter. So with that many computers, one of them was always broken, and I ended up being the keeper of the test stand machine where you'd swap parts out, and occasionally somebody from Data General would come out and use that to fix them. So one day, Bob had designed an Arpanet interface for the Xerox clone of a PDP-10, which was front-ended by Data General Nova. So his Arpanet interface plugged into the Data General Nova. And he built it, and it worked. Then they wanted to build another copy of the PDP-10 clone, and so they needed another Arpanet interface. Well, Bob's drawings weren't really quite up to date, and he wasn't really sure he could build the second one. So he had him wire it up with whatever he had, and then he needed a machine to debug it in. So he came to me because I had the test stand machine. So we spent a couple of weeks figuring out all the changes that he'd put into the first Arpanet interface that he never wrote down in the schematics. And then little did I know at the time, he was writing all those memos, inventing Ethernot. And so he started explaining it to me, and the pressure was growing on him to stop writing memos and start building hardware. So he'd been working with me. He knew he got along with me, I guess. So he turned to me and said, "Would you like to help me build this idea?" And he handed me a stack of memos, and that's how I heard about Ethernot.
Fabulous. Radia, you look like you're just about to ask a question.
No.
Good.
Just-
Well, I have a question for you. So I know that there are some who we call Radia the mother of the internet, which here in California we all share in her wincing at because it is so politically incorrect to put. And I would actually invite the audience, we need a better phrase for this, because father of the internet sounds okay. Mother of the internet doesn't quite work. So we need a gender neutral name. This would be a good innovation for the industry to come up with. But leaving that aside, just how did the internet evolve?
Okay, well, actually,
Coming out of it.
I'll talk sort of about the spanning tree piece of Ethernet. But first, I'll say that, gee, in keeping with this event, this protocol for asking questions, raising your hand, shouldn't it be like CSMACD that you just kind of...
Awesome. Okay.
Right, but at any rate...
Hand raising is over. Just barge in at any time.
Right.
And we'll do the error correction up here.
Right. Oh, and the other comment about CSMACD is that I seem to have it ingrained in me. I just sort of, that's the way I behave. I cannot interrupt somebody, and if somebody interrupts me, I just stop. But I'm always amused at meetings when there's other people that don't seem to understand CSMACD, and whenever they feel like talking, they just talk, even if someone else is talking, and they'll keep talking. You have 5 minutes. Anyway, so
That's actually most software engineers I know.
Right. So back to spanning tree. So I was the layer 3 designer for DECNet, which meant that it's how you piece together a bunch of links and have the network self-forming and figure out how to move the data around with intelligent switches. That's another way to hook up a bunch of computers. So, and all the links were like point to point. It was only 2 computers. And then along came the Ethernet, and it was like, a new kind of link that I have to redesign the routing protocol to be efficient with this new kind of link. So I applaud the inventors of Ethernet. It's really cool technology, but they should have called it Etherlink and not Ethernet, because, it was all like bright and shiny, and everyone got all confused. And they thought it was instead of layer 3. And so they were building applications directly on Ethernet and leaving out layer 3. Ethernet was intended to be just a single link with, a limited number of computers and distance that you could do. So I tried to argue with them and say, hey, you still need layer 3. And they said,
How'd that work out?
Right. They said, oh, go away, Radia. You're just upset because no one needs your layer anymore. And I said, but you may want to talk from one Ethernet to another. And they said, our customers would never want to do that. So years later, my manager says, gee, we need to figure out a way, a magic box that will sit between two Ethernets and let someone over here talk to somebody over there. But of course, the constraint was we couldn't change the Ethernet packet in any way. We couldn't increase its length. There was not a single spare bit. And we couldn't change the way the end nodes worked. There were end nodes that thought they were speaking on a single link. So they had pretty much agreed that, well, you just kind of listen promiscuously and forward the Ethernet packets around, but there needed to be a spanning tree algorithm, which is spanning means reaches everybody, and tree means no loops, because that wouldn't work if there was multiple ways to do that. So my manager suggested this problem on a Friday, and and he was going to be gone all the next week. I realized that night how to do it, and it was trivial, and it was like incredible. I could prove it worked and all that. I spent Monday and Tuesday writing the spec in enough detail that people got it working without even asking me a single question in just a couple months. And the remainder of the week, because I couldn't concentrate on anything else, I had to show off to my manager, and he was away, and this was before cell phones or email or electricity or whatever. So I spent the remainder of the week working on the poem that goes along with the algorithm, which was the abstract of the paper in which it was published.
There was some controversy at that time about whether this should or shouldn't be included in the bridge, because the hardware development team's default position was no extra stuff, period. And it's not a bad position for a hardware team to say, I want it to be as simple as possible, but no simpler. And so they said, we don't have it in repeaters, so we don't need it in bridges.
And that's another actually really interesting story, which was that I found out afterwards that the very first bridge that Digital sold was to the world's most sophisticated customer. And they were, I found out afterwards that they were saying, oh, we're doing all this complicated stuff. And the Digital salesperson was saying, it's just going to work. And they were saying, but we're doing this complicated stuff. So the world's most sophisticated networking customer had the world's simplest topology, which was two Ethernets and one bridge. And they plugged it together, and it didn't work. And they were like really upset. And when field service went to figure out what had happened, they realized this sophisticated customer had plugged both ends of the bridge into the same Ethernet cable. And so everything was working perfectly. The spanning tree algorithm said, hey, I don't need to forward. If I ever do, I will. You're right.
Yeah, a related disaster, and there are certainly many disasters along the way that got fixed, before the first bridge was sold was we said, well, let's resolve this question about whether there should be a routing algorithm in the bridges. And so down in our lab in Hudson, Massachusetts, where corporate research had moved, we built one with a PDP-11 and a couple of Unibus adapters, and it was way bigger than that podium, and hooked it up on a Friday, went away, and then sometime over the weekend, somebody in there created a loop, plugged it in, and it brought down the entire Hudson facility. That's now an Intel semiconductor facility. At the time, they were running a distributed simulations for the development of the Microvax computer, using every computer in the building. And Bob Supnick's head exploded at that point, and it landed directly in front of me, and it was yelling at me. And so that got pulled off, and he said, you ought to just pull corporate research off of this network as well, besides this experimental thing. And that resolved for the hardware team whether or not there was going to be a routing algorithm in the bridges, definitively.
So, Radia, I just want to go back to just one thing that caught my attention, what you said. You said, so I went home that evening and the solution occurred to me. And then you kind of moved on. It's like, well, so then magic happened, and oh, by the way, so what happened? What was the insight?
Oh, I mean, it's after the fact, you look at it and it's just sort of obvious, how to do this incredibly simple thing. Should I quote the poem?
Please.
Okay, so the poem is called Algorithm, because every algorithm should have an algorithm, and it's, I think that I shall never see a graph more lovely than a tree whose crucial property is loop-free connectivity, a tree which must be sure to span so packets can reach every LAN. First, the route must be selected. By ID, it is elected. Least cost paths from route are traced. In the tree, these paths are placed. A mesh is made by folks like me, then bridges find a spanning tree.
And by the way, this will be the sobriety test after cocktail hour tonight. Anybody who cannot recite that completely will not be allowed to drive home. They'll set up cots here in the Computer History Museum. So Norm, you're off in Hawaii.
I am.
Tooling along, you're a professor, doing your research. At what point did you begin to suspect there was something weird going on in Silicon Valley?
Well, I got to Hawaii by spending 10 years in Silicon Valley. So I knew long before I got to Hawaii that there was something weird in Silicon Valley. I don't know when that struck Bob, but Bob was as he usually is, very gracious in crediting the work in ALOHA to what he brought to fruition in so many other places. And
so he had while he was looking for that chapter in his thesis, he had contacted you, of course.
No, he only contacted me when he finally got to Hawaii. And in fact, the whole process by which Bob got to Hawaii is one of these things that's sort of shrouded in the mysteries of networking. I don't know how it occurred. Bob says I invited him from time to time.
I thought it had something to do with the statute of limitations and jurisdiction, but...
It may have to do with the passage of time, but I don't think there's any statute involved. The first I knew is that Bob showed up as perhaps the only pre-doc, post-doc I've ever known. That is, Bob had not got his degree, I believe, when he got to Hawaii. He was still fighting with the people at Harvard. And the work that he did in Hawaii was helpful to us. Bob was involved with a lot of our graduate students, and Bob and I talked from time to time. But it was networking from the point of view of the ALOHA net. And perhaps one of the things that I should bring up is a question that was mentioned just peripherally in Bob's statement here. He's talked about the path from ALOHA to Ethernot. Of course, if you take a look around at all the computers that you see at the various desks here, everybody's connected not by Ethernet, but by Wi-Fi. And so there is a road from Ethernet to ALOHA that is interesting to me as well. And it seems to be the way in which things are going. With a great deal of pleasure, I noticed that the movement to the wireless end of what's going on in Ethernet seems a lot more robust and also a lot more lasting, I think, than the wired version of ALOHA, which Bob brought out. But I certainly see Bob as having invented both.
So instead of ALOHA being the Ethernet, that Ethernet is the ALOHA, and it's only appropriate that ALOHA means both hello and goodbye. So 40 years ago you said hello to the Ethernet. Now it's like, well, so long, it's ALOHA's future.
And we really haven't said goodbye to the Ethernet,
yes.
But we have said hello to ALOHA again after a hiatus of perhaps 20 years. That hiatus, by the way, was not a technology hiatus, it was a regulatory hiatus until the frequencies were available for the connections that we all use today, there was no sense in going from Ethernet to Wi-Fi or ALOHA.
So Bill, you of course have been in the thick of all this, and one thing I should share is that we all have had this really wonderful email exchange before this panel, and I have got like 10 pages of really cool stories. Bill told some of the best, and I don't even know where to begin, but Bill, what was the part you thought that was most likely to fail in all of this?
Well, there was a whole list of things, but because it's much easier on the ladder of credibility to sort of fall off at any point than to actually get to the top in commercialization. For example, Jerry Salzer at MIT had written a paper, Why a Ring, which was all of the arguments for token rings. And this was back in the sort of early 1980 timeframe when we were building the 10 megabit Ethernet. And I put it on my cubicle. We were in the mill at DEC at the time with a dart, the kind you use in a bar. I just put it there and made sure you went down that list. And he said, a few things like they'll never get the random numbers generators to work. And so we said, oh, we can do that. And so we had a design, we got it, going and everything. And we built much to the annoyance of Intel at the time, because with the digital Intel Xerox, I think there was an implicit assumption that we were just going to use the Intel chip. So in order to fulfill that assumption, we designed our own chip and then licensed it to AMD and MOSTech, figuring between the three of them, somebody would get it right, and that would drive the cost down and the bugs out and create a dynamic. The commercial terms on it were tremendous in terms of what we would have to pay. And so we designed that. We built 3 emulators of the chip and ran it, and we were trying to make sure everything really worked for commercialization. And over the weekend, all the systems drifted into sync. And so the collisions were back off, so it was permanent. There were 0 packets going through the system. It would lock up. The closer the crystals were in frequency, the longer it would take to drift into sync, and the longer they would be in sync once the random number generators were synchronized. So this created a fire drill. Bernie Lecroute, who was running, he was sort of the division manager before he had left to go to Sun. We called him the Crusher. I'll tell you offline why.
No, we'll just TTY interrupt. I think you need to explain Crusher.
Well, because a couple of us had gone and wanted a little bit more time, and because I had found some issues in the back-off algorithm in these simulations we were running, that this could be fixed and so forth, and so we just needed a little more time. And one person made the mistake of saying, Bernie, you can't get blood from a rock, and he says, no, but I can crush a rock, and he just crumbled up the paper and threw it. So he became called that Crusher. And so the things drifted into sync, and so we were all locked in a virtual room by Bernie and management to fix that problem. And the reason we wanted it fixed, and this relates to, I think, one of the very important commercial dynamics that was established with the 10 megabit, which was establishing a dynamic in the industry with semiconductors. And that's why we had all these implementations out, and we wanted to make sure the core piece was correct. So we built test dies at AMD. We came up with, there's not enough time to go into how it works, but we came up with a pretty elegant fix for that, and then we would channel that to semiconductors. One of the other companies in the collaboration didn't believe it was a problem because they built one emulator and it didn't drift into sync, and that remained a problem until many years.
So, first of all, if there are audience questions and comments, well, actually, would everybody in this room who had something to do with the evolution of Ethernet raise your hand?
Yes, that's true, right?
Come on, the people haven't raised their hand that I know. That was the echoes of Token Ring. It's what happens when you do it in the ring. That's why trees are better.
This proves success has many fathers, but failure is an orphan. And I think Ethernet was particularly promiscuous in that regard.
Yeah, so question, just a follow-on question for you, Bill. Innovation, and Bob has written on this extensively, that we think of innovation, it's about technology, but of course it's about social processes, it's about interaction, and some of those can be quite colorful. We have a saying in the Valley many years ago that it's, for entrepreneurs, it's easier to ask for forgiveness and permission. Tell us about the time you got in a shouting match with Ken Olsen.
Well,
I mean, I know there was more than one, but...
when one person is doing the talking and the other person is trembling, it's hard to call it a shouting match. What transpired was, for some reason, the program manager thought it would be good for me to give the status report to the executive committee at Digital, at DEC, at the time it was called DEC. And so he warned me that if Ken Olsen is humming or looking around, you're probably in trouble. And so I was giving this presentation on the status of what we were doing, and all of a sudden he was standing up at the end of the table, which seemed now to be as long as this room to me. It wasn't, but it sort of felt that way. And he says, "What does your badge say, son?" And I said, digital, and he says, does it say DEC or industry? I want to, and he said, why are you giving away my technology to the industry? And I thought this was interesting, and the simulations I had were called the DEC wire simulation. It wasn't called the Ethernet simulation. But nevertheless, we were trying to get it out into semiconductors and standardize so forth. The standards were just really getting going. That's a whole other topic in IEEE.
Well, Micro, I always thought that Ken's problem was he had a DEC wish, but
yeah. Well, so I said, well, I think the strategy is it's better to get a big piece of a small pie than a small piece of a little pie, or than all of a little pie. And so afterwards, I asked him, do you support this? Should I get on another project or something? He said, oh, no. I just wanted to see if you were going to be a leader or anything, because you need to have arrows in the back from your friends, in the front from your enemies. So it was great. Head games.
Oh, my gosh.
Oh, and just sort of a technical point. Other than the radio stuff, the Wi-Fi stuff, mostly Ethernet isn't CSMA CD anymore. It's just point-to-point links with, sort of a half-hearted layer 3 protocol, which is the spanning tree. But that was because, it wasn't designed to be doing that. But one of the other, one of the real innovations of Ethernet was the 6-byte address, which was a crazy idea because IP only had a 4-byte address and was intended to be the entire world. And Ethernet was designed for a few hundred nodes on a single wire. Why would they come up with 6 bytes? But this notion that you wouldn't have to configure things, that it would get born with a unique ID that you could carry around with you wherever you are, was like a really cool idea.
Indeed. And, speaking of that, so about that radio thing, Dave, you really brought into this a radio aesthetic. As I recall, you're an extra class amateur radio operator, correct? Yeah. And so, to us on the outside, it looked like Ethernet was like, the idea was, oh, this is radio down coax. And I know that's a grotesque oversimplification, but how did your, radio perspective inform your design?
Well, it's not reliable. I mean, radio isn't, and you have to, somebody can always say, repeat, please. Something wiped it out, and so retransmissions and let's see, amateur radio people used to run message networks where they would accept written messages and send them by Morse code. And so I was quite familiar with checksums and retransmissions and all of that. So when Bob sort of said it to me, I said, oh, yeah, I understand all that.
Yeah, because it's fascinating to me that Bob came in, he discovered ALOHANet, but I think of Bob's many accomplishments, he's not a radio geek.
Well, Paul, if you go all the way back to Bob's initially rejected thesis at Harvard, you'll find a description of the architecture of what he was thinking of in his PhD thesis. And Bob used the term, which I subsequently adopted in a couple of papers, was never widely adopted, but I thought was very insightful. He used the term packet broadcasting. And so it seemed to me that right from the beginning, Bob was thinking radio, but thinking radio on a wire. That is, he was broadcasting on the wire.
ALOHANet. Bob talked about the ALOHANet all the time. It was really the model that he was trying to just translate onto a wire.
Yeah, and he was grounded in radio, but he was constrained by the same thing that all of us were constrained about in those days, the FCC.
Yeah.
The FCC would not allow you to do this, and it took some it took some very inventive people within the structure of the FCC over the years to put us all on these little wireless units that we use today.
Yeah, fascinating. So we had a comment. Two thoughts I have as one is, the innovation process is process of recombining things from other fields really played out here. It was really a recombination of multiple perspectives. Also, the more I listen to this, the more I think about Bob's PhD getting rejected. I think I missed my opportunity. If I'd gotten expelled from Harvard in freshman year, maybe I would have had a real career, but who knows? Sir, tell us who you are.
I'm another Bob Emerson, freelance writer. Earlier, a few minutes ago, Radia, you said that we don't have CSMA, CSCD, I can't remember the acronym anymore. What happened to it? I mean, what allowed it to go away?
Right, well, it just, it turned out that it's kind of evolved to just having intelligent switches and point-to-point links, just like kind of layer 3 was, was going to do. I was actually on a panel once at a conference. I was innocently there, and somebody said, oh, I want you to be representing Ethernet versus Token Ring. And so I read up at first I said, oh, that's kind of hardware stuff, and I'd rather not. And they said, too bad, everybody else has already said no, so you can't say no. So I thought I could do a really good job of advocating for Ethernet against Token Ring. And then I found out there was a third guy on the panel who was actually Sandy Frazier from Bell Labs, who I hadn't heard of at that point. And he was talking about star topologies, which didn't worry me. That was clearly stupid. It's a single point of failure. And then he talked first and just completely blew us away. So like with single point of failure, he said, look at this topology, looks like a single point of failure. But if look at Ethernet, where every component is a single point of failure. Every transceiver, any one of them sort of misbehaving, the whole thing is down. And so I was thinking, is he just sort of really smart and he could have taken any position and, and blown us away? Or might he be right? So it turned out that he was kind of right, that the best way to kind of cheaply hook up a building was with, like a more intelligent hub and, hook everything together. And it's actually easier to isolate things. And then
basically all the things we argued against in the original thing, which is that picture that had the single wire and so forth, and the twisted pair and a single point in a wiring closet.
Right.
We were going to get rid of twisted pair and wiring closets. Whoops.
Right. And then, like if you couldn't have an intelligent thing with 10,000 ports, you hook them into each other to get more ports, and then you need the spanning tree. And so, that's sort of how it evolved to be like a better way of doing things. But the packet format remains. So it's not clear when
Actually,
people talk
I
about
have it here.
Ethernet.
This is the last remaining thing from the Digital Intel Xerox Blue Book. It's page 27. It's the packet format. It's right here. It's the final thing that's left. However, just one comment about that, though, is it may sound pithy to say, well, we were going to get rid of twisted pair, and now we're on twisted pair and get rid of the Ethernet. The process and the core seeding, the core technology that seeded the industry, and then the standards environment, and a design which was just simple enough that pretty much anybody could get it to work, as opposed to you had to be a rocket scientist and everything had to be precisely the same, like a token ring, Christmas tree lights in series kind of deal. That allowed a industry dynamic where Ethernet could evolve in a sort of a just-in-time environment. So just when things sort of run out of steam, there's sort of a spring comes to the Ethernet and it reinvents itself, it gets reinvented. And that's the engine that's going on now. And there isn't any particular reason for it to stop.
And that's a perfect final thought. It's just the frustrating thing about today is I feel like we're just getting started on this panel, but of course we're out of time. So please join with me in giving our panelists a hand. Good, and we're going to do a quick reset to the next pass. If you all exit off that way, you'll get a chance to, either direction is fine, whichever you would like. But, good. Yes. Okay, so our next panelists are all headed up, and you'll find your spot that, and actually what would be good is if you, this is good. So it's going to be Bob, Dan, John, Pat, you're right next to me. Okay, so this, John, good to see you, sir. So this panel is titled Ethernet or Ethernot, Ethernet and the competing technologies. And again, in the spirit of saving time for the actual panelists, I'm going to introduce everybody with just one word. So way off at the far end, Bob Belleville, AppleTalk. And then Dan's next. Dan, Standardized Token Ring. John Schach, PUP. And I'm going to add a second word, or two words, first virus. He'll never live that down. And last but not least, Pat Thaler, 10 base T. I got it right today. So let's dive in here. Bob, I actually would like to start with you. You spent time, of course, on Engelbart's Augment world, and then you came to Park. How did your experience with Engelbart inform what you did afterwards?
The SRI experience was very formative for me because I joined Doug Engelbart's group in 1974, and at that point, we had the network available just as a tool to use. We weren't developing at all. I remember very clearly one day and sitting there with an online conference with a guy at MIT sitting in Menlo Park with a video projector showing his slides and Doug talking about the system that we were talking about. Had nothing to do with the network or anything. That was already in 1974 so transparent when I got there that we didn't spend a lot of time thinking about it. And so that's a lot about how that came about.
Yeah, I mean, we had, and again, talking about sort of the context out of which Ethernet emerged, and we think of ALOHA.net and the like, but Doug Engelbart's Augment program, of course, was spun out people like you who went on to do extraordinary things. Just a quick show of hands, who in this room worked at SRI or with Doug Engelbart? Come on, raise your hand, Bob, yes. So we only, 1, 2, 3, did I see 3 or 4? Good, okay, yes, thank you. Dan, so Token Ring has been the subject of several jokes so far. Would you like to set the history correct around this?
Sure, unfairly maligned. And let me dispel a myth right at the beginning.
That means you, Bob Metcalfe.
Giving Bob Metcalfe 10 years of nightmares was not our primary goal. Now, we make such a big deal about competing technologies and Token Ring and Ethernet and Token Bus. That's because in those days, the medium access control was different. Once we got to switch to Ethernet, it became kind of irrelevant. What I think was the primary accomplishment of that whole effort was 2 things: the frame format and the MAC service interface. It says we have a MAC layer, it'll attempt to do these things, there's no recovery at the MAC layer. That has sustained us to this day. That's really what Ethernet is right now, a frame format and a MAC service interface. And the universally administered addresses I thought were brilliant. I spent a lot of my time in 3 committees in IEEE 802, and I was responsible for the worldwide standardization of local area network everything for IBM. 802.5 for the token ring, 802.2 for logical link control, 802.1 for overall architecture addressing and bridging. And IBM had contrary opinions on everything. But the reason wasn't to be abstruse. The reason was that our customers were the banks. And they absolutely required reliable, predictable delivery of bits and services. And we could deliver that with Token Ring, whereas in those days you couldn't deliver it with CSMA CD and this cable that strung around the ceilings. So we had a legitimate business reason for wanting Token Ring against Ethernet, for wanting connection-oriented logical link control instead of connectionless, and for wanting source routing bridging instead of spanning tree. So I took a lot of arrows during those years. No one was happy to see me walk into the room, but I will say this about the whole experience. We were arguing about really interesting technical matters and really interesting business justifications. And except for a few individuals whose names I will not recite right now, there was really a large absence of personal animosity. And I became really good friends with my counterparts at Digital and the other companies. And we went on to do some really great things together in FDDI and later in that. And of course, we ended up in some of the same companies. But it's fun to go back and think about the things we were arguing about back then that aren't the things we argue about anymore.
Jump in, John.
So I cannot resist that we are still discussing and rationalizing this bullshit 40 years later. I mean, I am just back in time. Let me pick up on 2 comments. The first one is importantly, and Radia mentioned it as well, about what it is we're celebrating today. And it is the 40th anniversary of the Ethernet memo, carrier sense multiple access, shared cable, collision detection, and all the rest of it, which, by the way, none of them are in the Ethernet today. Not one. And as I think Bob has said once, it's been a long time since the insurance companies have heard a complaint about a collision between 2 packets. It just doesn't happen anymore. And the key commonality to be Ethernet compatible today is really the addressing. And there's a long story about how 8-bit addressing in the experimental Ethernet and in PUP and the problems we had there and why it evolved in later Ethernets and in XNS is one of the most important stories here. And the X-wire spec, which people forget about, was the internal 2nd generation that was going to be done at Xerox. And I think, Bob, you and others had stuff to do with that. It had proposed a 32-bit address. And by the time we proposed the standard with DEC and 2DEC and Intel, it had gone up to a 48-bit absolute identifier, unique over all space and time. This is an unbelievably crazy and key idea to the success of the Ethernet, 2 to the 48th devices. And Yogan, are you here? Raise your hand. Is Bob
Yogan
Prentice here?
Where are you, Yogan?
Yogan is over here.
Good.
And
Get
Bob
a mic
Prentice,
to him.
who worked on it, and I think Yogan, you've attributed some of it to Will Crowther.
Yogan, keep your hand up so they can get a mic
for
to you.
people who haven't read it, you know, this is the one paper in all of networking. I'll leave aside my own. This is the best paper I didn't write on 48-bit absolute addressing, and I wish I'd written this paper, that it endures as it does, and you know, it is really an important paper, an important cosmic idea, which has allowed us to have generation after generation after generation of things that are called the Ethernet, and yet can interoperate at a very efficient way because of this mind-stretching idea of every device will be born with an identifier that will, you know, last its lifetime. So that's point number one. Point number two, let me talk a little bit about my view, which is different on...
Actually, hold that. Let's give Yogan a chance to add some color. Stand up. This is what happens when you get called on by friends.
All right. Well, it's a long time ago, but John is absolutely right. It's probably the most unique idea that came out of Xerox when we were working on Ethernet. And Will Crowther and a number of other people are credited with the idea of saying you don't have relative host IDs, you should really have something that's absolute. And that was born with the experiences that people at Xerox had with PUP and the first generation of Ethernet, and I and other people had with the development of TCP/IP at Stanford. But it was such a bold idea, and I must say that when you're young, you can have the hubris, because when we were working with DEC and Intel, the Intel engineers told us that there was no way in hell they could put an absolute unique ID in every single chip that they would create for Ethernet. And being young, we told them that they were Intel and they better figure out how to do it. And to their credit, they did. And that really is the most unique idea, that every single node should be born with an independent address, and then you can map that address however you wish to TCP/IP addresses or IPv6 or things of that nature. So a number of people contributed to that effort, but it was sort of a mind-stretching exercise where you could actually think about giving every node. In those days, nobody thought there'd be 2 to the power of 48 nodes. And 48 bits was a lot of bits in those days. Now, I know everyone thinks about 64 and 128, but it was quite a stretch.
We have another comment.
I just want to add something to
Say
that.
who you are.
I'm the same person who was up there earlier.
Yeah, I know, but not everybody can see you from here. So, Bill, say who you are.
I'm Bill Hawe.
Yeah.
And Jeff Thompson and I were just talking about it. I think this is essential. Addressing is architecture, and I totally agree with what you've said, but we should not lose sight of the type field, with the protocol identifier field, because that was a key enabler, because at the time, again, this is circa 1979, circa 80, which is the single protocol you would want to run on the Ethernet? There isn't one, and that was a key enabler. Yes? So those two are essential to the longevity. Right now it's IP, and so maybe doesn't matter as much, but at that time, if you didn't have the type field, you wouldn't have been able to bootstrap this.
Good, thanks. Okay, so.
Jeff Thompson again. Just agreeing even more with Bill than he thinks, because even though much of Ethernet freight is IP, the type field has proved essential for many of the recent innovations in terms of VLAN technology that it provided for encapsulation. It's been the keystone of the long-term flexibility of Ethernet. And in terms of addressing, I happen to be on the committee which provides technical advice to the registration authority for selling addresses. And the thing that we're concerned about is trying to make sure that the address space lasts 100 years. We're now 33 years into that, and so far we've done okay, but there are danger signals on the horizon, and that's because Ethernet devices have become so cheap that they're now just several sectors on a disk drive in a cloud somewhere. And that's taken the limits off the number that can be created. So we have real concerns about whether or not we can preserve the addressing scheme in the long term.
Right. A challenge we're dealing with right now is both addressing for virtual devices, which 48 bits has been good for physical devices, at least as long as the physical devices are things like computers. But when you start having virtual devices, you can consume an awful lot of addresses. And then the other issue is the whole Internet of Things, the smaller and smaller devices that are getting addresses. And so that's something we're coping with and probably going to start using the local address space more for some of these kinds of things. You know, I also wanted to respond to my friend Dan here, and my line is that Ethernet, the original Ethernet, had a deterministic physical layer with a probabilistic MAC layer. In other words, we relied on probability for the CSMACD algorithm, whereas Token Ring had a deterministic MAC layer but a probabilistic physical layer. If they lost a packet, they had to regenerate the token, and that took considerable time. And then the other thing is that I put a comment in on the original ballot on the Token Ring standard that they didn't have their PLL specified well enough to ensure interoperability, and they assured me they did and didn't change anything, and then some years later dealt with the jitter accumulation problem. So,
do you remember our beautiful hermaphroditic connector?
Yeah, well, that was the other thing, is beautiful ergonomic design on the connector, which was huge. I mean, people today complain that the RJ45 that you plug 10 base T and the twisted pair standards with is too big. But this was like about this big. And the thing is, they had a lovely shielded cable, a much heavier duty, stiffer cable than we use for Ethernet. But on that, they put this huge connector where they put the shield around in a U, and the sides of it were open, and the pairs were unbalanced with respect to those open sides. And so when they plugged it into a grounded wiring panel, it unbalanced the pairs. So I think one of the things that Ethernet has done a great job of over the years, with a couple of little stumbles along the way that we fixed, but generally done a great job about, is a really solid physical layer design. And so that when people bought new Ethernet physical layers and plugged them together, they worked. When we did 10 base T, and a lot of people gave us a lot of grief about making sure this was a bulletproof physical layer, because there were people who felt that twisted pair was not Ethernet, and moving to twisted pair was not Ethernet. And we were really careful. And we had our first plug fest where we brought everything together, about 10 or 15 different vendors plugging twisted pair implementations together for the first time. And the only interoperability problem we had was that some of the devices had the wrong software loaded, so we had some upper layer issues with getting it to work at first. But there were no twisted pair interoperability issues. There were no issues with the spec we wrote and the ability of many companies to design implementations and bring them together and have them work. And that's, I think, really what Ethernet got right over the years, is the balance of innovation, people being able to do new things, and openness, a standard that really you could pick up that standard and design a device, and somebody else could pick up that standard and design a device, and they would work together. And so over time, basically as soon as we brought out 10 base T, we went to a star network with a repeater. You could only have 2 devices on the twisted pair, 1 on each end. And we went to a star network with a repeater, and that changed the paradigm from all the original networks, which were either buses or rings, to the star network that Radia mentioned. And then we continued to argue about access method until the mid-90s, when that repeater turned into a bridge. And at that point, the access algorithm, the details of it, other than the CRC check and the frame integrity checks, went away. And really, we were dealing with a star network, and people now relied on electronics to work. It wasn't the electronics that broke most often, it was the connector getting flaky, or somebody making a user error like taking the terminator off. And so we found that the original idea of stars and rings, that you couldn't rely on these electronic components in the center of the network, was incorrect, and we switched to it. Now, if we want more reliability, we put in dual paths and have 2 paths through the network.
All I can say is I'm interested in hearing more about the hermaphroditic connector afterwards, because by coincidence this weekend I had what I thought was a bad Ethernet cable between the laser printer in my cottage and my home office, and I wasted about 3 hours trying to diagnose it until I realized it was what in the age of radio they referred to as a short between the ears, that my post-50-year-old eyes had run the wires in the RJ jack wrong. So I would vote for bigger connectors, as big as possible. John, you were about to make a second point 10 minutes ago, and I want to...
No, this has been a good discussion. I would like to take a minute or two on sort of token ring versus Ethernet. And to put it in context, the wonderful story that I look at is about AC power and DC power. There's a great biography of Nikola Tesla that many of you have probably read, and I recommend to where it describes this. Thomas Edison had developed a distribution system and power generation system based on direct current. Nikola Tesla had developed a set of ideas around alternating current, and so there was a technical dimension to it, there was a business dimension to it, and there was a political and marketing dimension to it. So Tesla was backed by Westinghouse, Edison was backed by and helped form GE, and they battled over who would get the contracts for certain power stations and which was the better design technically, which one had the better business support. And it devolved from a technical fight, which it should have been at one level, into a business and political fight, including Edison staging demonstrations where he would get a stray cat and electrocute it with alternating current to show that this was dangerous and there's no way that you should allow alternating current into your house, failing to point out that if you'd put the same direct current through the cat would die just as well. And this was a very bitter struggle at a technical level, a personal level, a business level, a marketing level, which eventually Westinghouse and Tesla won. They got some big orders for some power plants, and then ultimately GE, to their credit, shifted gears, dumped DC, and got into the AC business and really succeeded at it. So, when we take that and consider the token ring versus the Ethernet, there are technical issues, there are business issues, there are marketing issues, there are positioning issues. I mean, to this day, I believe it is an absolute fact that the token ring causes cancer and the Ethernet cures cancer. This was the level.
Okay, vote in the audience for the proposition. Raise your hand.
This was the level of debate, and there was a lot of scurrilous bullscat, that was spread around, and there were technical differences of opinion about rings, and there had been rings forever, by the way, Newhall and Farmer, guys at AT&T, and others, and there had been bus networks, and it became in the standards, when we arrived at the standards body, having already produced, actually I am regrettably an attendee at the very first meeting of the IEEE 802 committee, before there were any subcommittees, which was held at the Jack Tar Hotel in San Francisco in conjunction with CompCon, conference that many people don't remember. And we had just about finished the Xerox DEC Intel joint effort, but we didn't quite have it ready for that first meeting. And so when we later presented it, this produced what I view as a political backlash about whether Xerox DEC and Intel were going to be able to have this unified front, align other people, and have a standard, which would make life more difficult for a different IBM than we have today. That's fair. And the battle had many different dimensions to it, with arguments about determinism and error and reliability, most of which was BS. That people would talk about determinism, and we'd point out, if someone takes apart your token ring cable and if someone takes apart your Ethernet cable, they're both going to fail. So let's talk about realistically, all of these are probabilistic systems. If you disconnect a token ring at the wrong moment and and you lose the token, there is an arbitrary process to get the token back. And by the way, if you get a second failure with some minuscule probability, you're going to have to go and generate the token again. And we had these obscure arguments about angels dancing on the head of a pin, which we finally settled in the IEEE. These were people who succeeded me because I couldn't stand it anymore, and as you can tell. And they finally said, fine, you guys go off into a different subcommittee and go away because your requirements are so crazy. Now, there's a particular medium which you may not be aware of. So in the midst of all this, we were promoting the Ethernet. We were getting good support from our partners and colleagues at DEC and Intel and other companies coming on board. And we were out working and recruiting people, and IBM was sort of on the other side trying to figure out how to throw boulders on the tracks. And we got a call, which I'm not certain, but might have been from Bob Evans, to our senior management that said, we understand he was a senior guy at IBM. We understand you're talking to people about the Ethernet. Would you be willing to talk to IBM? We said, sure, we're happy to talk to IBM. And this must have been in the time period, I was back in Palo Alto from corporate, so this was somewhere between around 80 or 81. And it was a classic IBM delegation, 6 or 8 guys, very smart guys. I believe it included Paul Green, Werner Bucks from Switzerland, from Zurich, a bunch of really smart guys, very disciplined, very gracious. And with a spokesman who had clearly been designated, who had his list of questions. They had clearly done their homework. And it was David Liddell and I against these guys. And David, unfortunately, is not here. And I'm sure everybody has a different recollection of this meeting. And they came in, and the guy had his list. He was the staff guy who would obviously put together all the questions. And it was like, well, we're trying to understand the Ethernet. If you had this set of requirements, can the Ethernet do that? Oh, yeah, of course. Ethernet will do that, no problem. Well, if you have this additional requirement, can Ethernet do that? Oh, yeah, no problem. This additional requirement, can it do this? So, yeah, we're pretty sure. We might run this little test, and there's a small pathological case, but yeah, we can probably do that. Well, if you had this requirement, and this requirement, and this requirement, and this requirement, and this requirement, can it do that? And it was like, you have to retrofit some devices, and you can add on hardware, and you can add as much processing power, but no memory. I mean, something insane. And we finally went, you got us. We don't think the Ethernet can do that. But who on earth has a requirement for a design that is that bad? And one of the IBM guys pokes the other guy and says, see, I told you your design was crazy. And I'm sitting there going, WTF, what is with these guys? So they're trying to solve some unusual, narrow, constrained, retrofit, real-time, whatever problem. And I walked out of the meeting and I said, they're going to be a problem, because they're IBM and they got a lot of weight to throw around and they have a point of view, but they are so confused and so screwed up. I said, although this is going to be hard, we're going to win this. And I said, it's either they don't understand their customers' requirements, they're deliberately misrepresenting their customer requirements, they are focused on the wrong requirements, or they are incompetent. And I concluded they were not incompetent, and just they were off trying to solve a different problem. Now, we still had to fight it out, and I cannot tell you how many speeches I gave to customers about the probability that somebody will cut your cable, be it Ethernet or token ring, is higher than the probability that any of these other bad things will happen to you. And eventually, all I can say, the final thing is, I dare anybody to go to Fry's and try to buy a token ring interface. I don't think they'll buy it.
So, good. So, last question. We're out of time, but I can't let this pass because I have a question for you, Dan, and a question for you, Bob. I want to start with you, Bob. When I look back, I think, for Christ's sake, this wasn't about people communicating information to other people. This all happened because people wanted to send data to a darn printer. At what point did, and thank God you all did that very well, I mean, at what point did it start dawning on all of you that this wasn't about sending data to printers, that this was a much, much, much bigger deal? And what does that mean for the future? What are we getting wrong today about networking that's going to surprise us ahead?
Well, I'll tell you two things about that.
Haiku, fast.
Okay, so in 1990, when I started taking my son to colleges to visit, to see which one he'd go to, and in the tours, they would talk about, well, they were getting one LAN connection per dorm room. And somebody used the phrase, their goal was to have one per pillow, one for every student in the dorms. That's when I knew that this had really gone big. And then as far as Ethernet curing cancer, when I had breast cancer and I was at the doctors at Kaiser, and basically every one of my doctors had access to all of the information about what had been done so far and could talk to me knowledgeably about it, and the meetings could be so efficient and good, and they could see the x-rays and everything. That's really, yes, it does cure cancer today.
It does cure. Now, it shows we still have a future because it hasn't cured the common cold yet. But Bob, your observation on this?
I was actually preparing to talk about the fact that I built the
Can you lean closer to the mic?
AppleTalk network principally to talk to a printer. The laser printer was very important to Apple's success, and we needed some way to share this very expensive piece of equipment, and that's the genesis of the AppleTalk network.
Steve was not a believer. He didn't even know what a network was when you talked to him, right?
Nobody at Apple particularly knew what a network was, or hardly anybody at Apple knew what a network was. But the thing that strikes me so much about the conversation that I've heard here so far is that we've been talking about a world that was dominated by the big research labs, the huge companies, the companies that actually had customers, like IBM. They had real live customers who had things to actually do. Apple, when I went there, was making the computer for the rest of us. There wasn't a customer base to speak of. There were a bunch of Apple II guys floating around, and there were high school teachers that had Apple IIs. But the small personal computer was only just beginning. The famous ad that Steve did in the Wall Street Journal about, or New York Times, about welcome IBM was very serious. This was a matter that the rest of people we knew were going to want these computer things. And the biggest idea that people had about that was that they were going to store their recipes on them. And we all knew that was different. It wasn't going to happen like that. But getting a lot of people involved. So the AppleTalk network I'm really proudest about, because it got the network into the hands of a lot of ordinary people who began to get a taste for this kind of a thing. Whatever they were doing with it, talking to a printer, talking to one another, sharing files, and all the things that could be done, the eventual development of email availability to ordinary people. That was something that was in 1983, when the AppleTalk network was developed, was all new. And so this was the bringing in of a vast number of people, which make all this stuff so interesting today. Not the environment of the banks, and not the environment of the people who had the university problem of putting up one by every pillow, but the problem of everybody was really going to want some piece of this at some point in time. And that was what I was so proud of about the AppleTalk network, is it helped to accomplish that.
That's great. So Dan, very last question for you. We're way out of time, but the arc of your career is actually pretty extraordinary. You went from IBM, through all this innovation in academics, and now you're the executive director of the Open Networking Foundation. So you've really continued to have an up-close view on how standards get set and evolve. Are you an optimist or a pessimist around the future of innovations in standards?
I think standards serve an important purpose. It's changing as even networking is becoming more software-based, and software standards are not the same as protocol standards. And we're trying to change that culture. But let me conclude with a limerick that I wrote in the period. This was in the late 80s. I'd been there throughout the 80s, and we'd done Token Ring, we'd done Ethernet, we did Token Bus, we got to Twisted Pair, we got to Switched Ethernet, we were doing FDDI. And I wrote this limerick. I looked around the room in IEEE 802, and I came up with this limerick. Any nitwit with standards acuity soon learns of their self-perpetuity. The work was all done back in March '81, but these trips are a lifetime annuity.
And what a perfect way to finish this panel. Please thank the panelists again. So now is a break. There's coffee. Are you going to come up and do a closing benediction? Terrific.
Great stuff. Thank you very much. And let's have a round for Paul as well. Great chairmanship. Well done. So yeah, we have a coffee break now. I just briefly want to say very quickly that the History Museum is looking for donations of equipment and whatever else it is. And if you want to go talk to Mark Webber, who's standing over at this side of the auditorium here, talk to him about anything you might want to donate to the museum. Okay? Other than that, that's it. Go have some coffee. See you later.